All right, guys, time to start our lecture for Unit 2, Day 3. By this time, you should have already done your do now, so your warm up for today. But if you haven't, pause the video, do it now, and we will begin. All right, so far we have learned about our atoms, right? That was the entire part of Unit 1, part of Unit 2 that we've already talked about, and we're going to go even further, right? And we started Unit 1 looking at an atomic model that looks like this, right? The Jimmy Neutron shirt, right? With my nucleus in the center and a bunch of rings around it, all right? And I want you guys to think to yourself, okay, this is one element here. Why does a similar diagram look pretty much completely different, right? If I still have my nucleus here, I have my electrons surrounding it. Why are they looking a little bit different? All right. So our objectives for today are that you can describe the structure of a Bohr model and how it relates to energy levels and positions of electrons. You're going to then be able to use that Bohr model to determine the number of valence electrons in that atom. And then you're going to be able to use the periodic table to determine the number of valence electrons in an atom and create an appropriate Lewis dot diagram. So if you need to pause the video to copy these down, do so now, but we are going to keep going. All right, I'm going to try to get this lecture done in 15 minutes or less. If not, there might be a part 2, so just a heads up. All right, so as we saw in the initial slide, right, we see depictions of atoms, all right? And one of the depictions of the atom, the one on the right, so this guy right here, is what we call a Bohr model. And a Bohr model is a model that we use, it's one of the models of the atoms that we use, that shows the electrons that exist at specific principal energy levels surrounding the nucleus. All right? Meaning, each circle around my nucleus, right? You see this one circle here and this one circle here, right? Each of those circles is a principal energy level, all right? Sorry, I keep moving around. I don't know how to click, right? And electrons only exist at these levels, not in between them, right? So that's why our electrons were on the lines themselves. All right, and we can also refer to our principal energy levels as shells or energy shells. And an easy way to know how many energy levels or energy shells my element will have is that it is equal to the period number of that element. So if I'm using my periodic table, right, and I find the element argon, I see that argon is in period number 3, which means it's going to have 3 principal energy levels or shells, meaning I have 3 circles around my nucleus, okay? Another example is strontium. Strontium is in period number 5. So it's going to have 5 energy levels or 5 circles around my nucleus. All right. And with the Bohr model, we have a rule that we must abide by, and that is your octet rule. Okay. And this only really applies to elements 1 through 18, and we're going to see why next week. Okay. But my octet rule states a couple things. 1, electrons will fill the shells that are closest to the nucleus first and then move out, right? So meaning if I have an element that is in period 3, so 3 energy levels, I'm going to fill energy level 1 before I move on to energy level 2 and then move on to energy level 3. All right. And each energy level cannot hold more than 8 electrons, okay? So 8 is my maximum, hence the name octet rule, like an octopus, right? An octopus has 8 tentacles, octet rule, 8 electrons. The only exception to that is your energy level 1, right? Your first shell can only hold 2 electrons maximum, right? And so we have a chart here. I refer to my electron levels, right? With n equals blank. N is my energy level or my principal energy level, right? So this is my first circle around my nucleus, then my second, then my third. And so my first can only hold a maximum of 2, then 8, then 8. All right? And when we're drawing a Bohr model, we have 3 steps that we go by. Okay, one is I'm going to draw out my nucleus, then I'm going to draw my energy levels, and then I'm going to fill in my electrons according to my octet rule. Right? So we're going to go through an example real fast before you guys get to some practice. All right? So an example that I have is if I have a carbon-12 atom. And we know from last unit that if I have carbon-12, carbon's element number 6, so I have 6 protons. And then 12 tells me my mass number, so I also have 6 neutrons, right? So I'm going to draw out my nucleus first. And I want to make sure that I am labeling that I have 6 protons and 6 neutrons here. Okay? This is wicked important, so make sure you have 6 protons, 6 neutrons. All right? Once you complete step 1, drawing out the nucleus, you can then draw out your energy levels, right? And I'm going to know how many energy levels I'm going to draw because carbon is in period number 2, right? So I'm going to have 2 energy levels, right? And so I would draw that out like this. Okay, so I now have 2 energy levels surrounding carbon. All right. And the next thing I then need to do is I need to fill in my electrons according to my octet rule. All right. If we have a neutral carbon-12 atom, right, my protons are equal to my electrons, meaning that carbon has 6 protons, so I'm going to have 6 electrons. So I'm going to start moving my blue dots that symbolize my electrons onto my element Bohr model to describe or to show you guys what to do, right? So we said if I have my first energy level, right, I fill up closest to the nucleus before moving outward. So I'm going to fill in my N equals 1 first, my first energy level, right? We said my first energy level holds a maximum of 2, right? So I'm going to move my first electron here and my second electron here, right? So I have 2 in that first energy level. But I still have, what? 1, 2, 3, 4, 5. I have an extra electron there, so I'm going to delete that. I still have 4 left, right? So I placed 2 out of my 6. Okay? And I have leftovers, which means I then move on to my second energy level, right? And my second energy level can hold 8, right? So let's start filling it out. 1. I'm going to fill it out. 2. I'm going to fill it out. 3. I'm going to fill it out. 4, right? And at this point, right, I don't max it out at 8, so I am done. All right, so this is how I'm going to draw my Bohr models. Okay, so the next part that we're going to talk about, let's see if, yeah, I should be able to get this done in before 15 minutes, so let's continue, okay? Once I know how to draw out my Bohr models, I can then talk about valence electrons, all right? Because we've been talking about energy shells, and valence electrons are your electrons that are in your outermost shell, meaning the shell that is furthest away from your nucleus, okay? And we talked about this when we were talking about families and groups on day 1 of this unit, and also when we were talking about trends. We know that elements in the same group or the same family are acting the same chemically, meaning, right, they have the same properties. And now we can go into the reasoning why behind it. It's because every element in the same group has the same number of valence electrons. All right. This Bohr model over here helps us see what we mean by valence electrons, right? If I look at this Bohr model, my outermost shell here is my second energy level, my N equals 2. And if I count up my electrons in this outermost shell, I have 1, 2, 3, 4, 5. So I'm going to have 5 valence electrons in this element, right? I clearly have more than 5 electrons total, but I only have 5 valence electrons. So I want to make sure that you guys write that in your notes before we move on to labeling the periodic table, because this is going to go pretty quickly. Make some sense once you catch on. All right. Because not only can we use a Bohr model to determine my number of valence electrons, but I can literally just use my periodic table, all right? And this is in your notes as well. So if I have a group 1 element, right? We said that all elements in the same group have the same number of valence electrons, right? So group 1 elements all have 1 valence electron. And it's super easy to remember that because group 1 is 1, right? Let's look at this, right? All elements in group 2, right, your alkaline earth metals, will have 2 valence electrons. All right. The next thing we're going to do, we're going to actually skip over all of my transition metals and we're going to go to group 13, okay? And this has 3 valence electrons. And we saw this similar trend when we were doing my A group, right? My 1A, 2A, 3A, right? So 13 ends in 3. I have 3 valence electrons, okay? Same thing with group 14 ends in 4. I have 4 valence electrons. 15 is 5. 16 is 6. 17, which are my halogens, are 7. And last but not least, if you haven't guessed it already, group 18, my noble gases, have 8. Okay. The only exception to this is helium only has 2 valence electrons, and that's because it only has 2 electrons to begin with, right? Element number 2 can only have 2 electrons total, so it will have 2 valence electrons. And the biggest things to keep in mind are, if I'm following my octet rule, I know that my energy level is full once I hit 8 in my outermost shell. So group 18, okay, is going to have a full energy level, all right? When it comes to transition metals, right, we skipped over that, so let's go back to transition metals, okay? These guys are kind of weird. They're only going to have 1 or 2 valence electrons depending on the element, and so they really don't follow a pattern, all right? What I am going to do now is I am going to have you guys do some practice, all right? These are in the bottom of the second page of your notes. And so I want you to draw the Bohr model, okay, following those steps that we outlined at the beginning of this lesson for each of the elements. And then based on your Bohr model, I want you to identify the number of valence electrons for each element, all right? I'm going to stop this video right here, okay, because I'm probably going to go over my 15-minute time limit with the screencasting that I use. But once you finish up with these notes and this practice, I want you to go to part 2 of today's lesson, okay, to finish up your note page on Lewis dot diagrams.